get to look at the homework very much. So I hope I don't have too many questions. Sorry if I'm not that helpful.
Yeah, no worries at all. It seems like a fairly simple lesson. It seemed like to me this chapter very similar to the last chapter. We're just dealing with different variables that we plug in.
Oh, really?
Yeah.
Okay.
So,
Gotcha.
so I think it's not going to be too bad. We'll see though.
Okay. Awesome. Well, you want to just jump in there and we can
Yep.
try to crank it out?
Sounds good to me.
Okay.
All right, 16 questions today.
That's not too bad.
Yeah.
I mean, maybe I was just thinking of the test. The test was like 40 questions.
That's a good point. All right.
I'm just pulling mine up really fast. Sorry.
You're fine, no worries.
Too bad you have a cold.
Yeah, I know. It was worse. It was mostly my throat on Saturday and Sunday. And both actually, my wife and I slept horribly Sunday night. My wife actually only got like an hour of sleep and started working on homework at 4 in the morning, and
That's terrible.
I got a couple hours with some very vivid dreams in between. It was really weird.
Wow.
Yeah. But I'm getting there.
That's interesting.
It's moved to more of my head now. I feel a little stuffed up and pressure headache, but I think it's getting better.
You're not as delusional as you were before, having like visions and things.
Exactly.
That's good.
Exactly.
That's good. All right, I have mine pulled up now, so I'm ready whenever you are. I'm on question 3 here.
All right, I can go ahead and read it. So in a pie chart, why are the slices or sectors different sizes? Oh, I remember just glancing over this part. Is it C?
Yeah, that's what I was just gonna say. That's
Yeah.
definitely C.
The other ones don't really make a whole lot of sense.
Yeah, I hear you. I think that one's right.
Yeah.
Okay, how are bar charts and Pareto charts related?
I think that one would be C as well, right?
Yeah, I think so. It's just ordered in a different way, right?
Yeah. Cool. So, excuse me. Use the following information for the next 3 questions. We can conclude that p hat is normally distributed if np is greater than or equal to 10, and that is also greater than or equal to 10. Is p the true portion or the sample portion? Excuse me.
Oh, you're good. That is a good question.
I have in my notes here that the p hat is the sample portion and just p is the population portion.
Okay, so that's the true portion then?
Yeah, I would assume so.
Okay, that makes sense. Awesome. Well, I'm already having questions on number 5, so hopefully this gets better, not worse.
There you
go. So what is N?
Sample size, right? That didn't change.
Yep, that is right. Knew that one.
If p equals 1/4, what is the smallest n that satisfies the requirement?
Wasn't it 10? I don't know. I remember seeing that number in the notes.
I don't remember. It could be. So for this, how do you figure that out?
So, oh, if P equals 1/4, what is the smallest n that satisfies? Oh. Good question. I'm looking in the notes really quick.
No, you're fine.
It was actually our turn to clean the ice center tonight, so we were
Hey, there you go.
there tonight.
Did you work the vacuum?
No, not this time. Just wiping backs of chairs.
I see. Vacuum's the best part.
Yeah. They're like Ghostbuster vacuums.
Exactly.
Yeah. Yeah.
Bless you.
Thomas just said bless you. Yeah, I actually don't remember. I don't remember reading like how to figure that out. I just
Yeah. Would we use one of the two equations up on top of question 5?
possibly. I'm not sure. Hmm. How large is large enough? So here it says at the bottom, like how large is large enough?
Okay, yeah, I actually just clicked that tab to that section.
Oh, really?
Uh-huh.
So, okay.
Which part were you looking at in it?
Yeah, just like the NP that's greater or less, or greater than or equal to 10,
Uh-huh.
or if n times 1 minus p is greater than or equal to 10. I don't know, does that? Nope, actually, I don't know if that is that.
Does this mean that we just have to maybe guess some answers to see?
Just to see if it's, find which one is greater than or equal to 10.
Yeah, because what it sounds like to me is both equations have to work out so that they're greater than or equal to 10.
That makes sense.
And so we'd have to maybe play around with some numbers with both the equations to see.
Okay.
I tried 10, and that didn't quite work.
Okay. Yeah. So in this example, so P is 1/4. What's the population? N? Or is that what we're solving?
It's P is 1/4.2.
Yeah. Yeah, and then N? What would N be? Isn't that the,
That's the one that we're solving for.
okay, that's it.
Yeah. Now, I don't know if this is true or not, but so it looks like the equation of NP is greater than or equal to 10. That equation would produce the smaller result if you were to use the same N and P as in the other equation. So I just multiplied 10 by 0.25, or the P value, to get 40. So that's the smallest possible number that you can get for that equation, so that N times P is greater than or equal to 10. And I assume it does meet the
The requirements.
yeah, there you go. requirements for the other equation as well.
Mm-hmm.
But I don't know if there's another number that would strangely work out differently or what.
Yeah, well, that sounds good. We could try it.
Okay. Give 40 a shot then.
Yeah, let's see.
Excuse me.
You're good. If you want, I can do all of the reading if it's.
Oh, you're fine. It's not a problem at all.
Okay, I'll read this one.
All right.
Use the following information to answer the next two questions. Suppose n equals 24 and p equals 0.4. What is the mean of p hat? Run answers to the 2th place. Alrighty. We got it from the mean.
I don't remember if this was for a specific problem during the videos or if it was some notes that I took. But for some reason, I have that the mean of p hat, which is what the question is asking for, is just simply equal to p.
Yeah, that I just looked that up in the book. It says it right here. The mean of p hat equals p. So.
Okay. Yeah, so 0.4 for that one.
Yeah, I was questioning myself when you said that. So I just said something.
Great minds think alike.
I guess. Okay. But for this one, we'll have to use the formula, right?
Yeah, the standard deviation formula.
So p hat equals square root of p times 1 minus p over n. Did you get 0.1?
I did, yep.
Okay.
Cool. All right, so Brittany's batting average is .300. We want to determine the probability she will get more than 35 hits in her next 100 at-bats. So n equals 100, p equals 0.3. What is p hat? That would be 0.3, correct?
Yeah. Yep.
Oh, 2 decimal places, 0.30. Okay. And then we're looking for the standard deviation.
Formulas are nice.
Yeah, I agree.
Sometimes. All right, I got 0.0458, but 446, I guess.
Yep, 0.046. That's what I got as well.
Z-score.
So I think this is actually something I was a little confused on. The top part of this equation to find the z-score, so p hat minus p, wouldn't that be 0?
Yeah, I assume so. Because it's the same value, right?
Yeah, at least that's what I remember.
Okay, so it's saying here that p hat equals the value, and then the p equals is the mean. So, so this example here, it has, for p hat, has 0.68 minus 0.5 for the p. So it's not the same value.
Huh. Okay, so it is different.
So, yeah, we're missing something.
Oh man, that means our standard deviation for the last one's wrong too.
Yeah.
I gotta take my sweater off really quickly.
Yeah, you're good. I wouldn't have known.
Good point.
Okay. Trying to figure out how to get that. Okay. Ooh, so the p hat is x divided by n.
And x is,
So x would be the, so if a coin is tossed 25 times and heads is observed 17 times, then you divide, and you're trying to find the proportion of heads. You divide 17 by 25, it's saying, to get the p hat. I don't know how.
So the total amount of flips would be whereas x was how many times you got what you look.
Yeah. So the bottom number would be the total. Yeah. The top one is the amount of whatever you're looking for.
So I think maybe then for question 9, I want to say that might stay the same because they didn't give us any other additional information.
Yeah.
About any other x value that there could be.
Yeah, I think you're right. And in the notes it said that. So maybe, like you're saying, if we don't have another value, then it just equals itself.
Okay.
Whereas sense.
This one we have some more values.
Yeah.
So the p hat could be different than 0.3.
Could be. So Brittany's batting average is 0.300. Would the batting average be the p hat?
0.300.
Because I think in the homework example, I think that's what they were getting, was the average of heads.
So then that would still make it 0 on top of the equation.
Yeah, you're right.
So gosh, that doesn't seem right. I was just thinking back to your coin toss, that example in relation to this. So the 25 coin tosses that you did might represent the 100 at-bats that are listed in this problem. And the 35 hits might represent the, 17 heads that she got.
So 30. Okay. So 35 divided by 100.
Right.
Yeah, so 0.35. Yep.
That sounds like a good answer to me. I
Yeah,
mean,
yeah, no, that sounds good. Let's try it.
perhaps we'll see.
Yeah, that's awesome. Okay, and then the standard deviation, we would just make that little correction, right? Little.
Do we need to change the standard deviation? Because I think P stays the same.
Nope, you are correct.
Okay.
Yeah, I think so. Okay,
Perfect.
now we're back to the z-score.
So the z-score would then be 0.5 divided by 0.046?
Yeah, I think so.
Okay. 3 decimal places. I got 10.870.
Well, that sounds good. I haven't worked it out yet, but
All right, no problem.
so the z-score formula is p hat minus p over the standard deviation formula, right?
Yes.
Which would just, yeah, we would just throw our answer under that. So 0.046.
Yeah.
So how did you set yours up again? Sorry.
Oh, you're fine. So the simplified version was 0.5 divided by 0.065, but basically it was 0.35 minus 0.3 on top divided by the square root of 0.3 parentheses 1 minus 0.3 divided by 100.
Yeah. Good. That's what we did. Thank you.
Yeah, no problem.
Thanks for being patient, letting me work through it.
Hey, that's no problem at all for me. I hope to be a patient person in life, so
Seems like you do a good job, Thomas.
sometimes not. Definitely much room for improvement there.
All right. Good. For some reason I still getting a weird answer, but hey, I trust you.
Let me work through it again just to make sure.
Okay. I'm just throwing it in the calculator here or something. You're good.
Did you, when you went through it, did you get 1.091?
No, I didn't actually.
Okay.
I got. Sorry, is that what you got that time or something?
Yeah, I tried putting the whole equation in at one time. What was it that you had gotten?
Yeah, actually, it may have been that I threw in the whole equation. And I got a different answer, but for some reason I just got -5.76. So something random. Well, I'm just gonna, so 10.870.
It could be that. It's kind of a high z-score, though, so I guess we'll see.
Yeah.
What is the
Yes.
probability Brittany gets at least 35 hits in her next 100 at-bats? So this is where we use the applet, right?
That sounds good.
Okay.
Yeah.
Okay, I think I got the wrong answer.
Okay.
Because I'm
Because
fairly
it's high.
certain the answer is not 8.01 times 10 to the negative 28.
All right. So the z-score formula. Okay. Yeah, we have that right.
Yeah. Oh, okay. On the top I put 0.5 instead of 0.05. That is quite a large difference too. Let me Okay, this makes a little more sense. This is actually close to what I got when I put the whole equation into the calculator at one time.
Yeah.
So I got 1.087 this time.
Oh, okay. That does sound good. Maybe I'll get. Yep, that's what I got. Awesome.
Cool. I was thinking that, geez, she's never gonna do that. Nigh impossible.
Yeah. Perfect. We're cruising. We're already on 13 here.
All right.
Okay, so the z-score, yeah, we just throw in the applet. You're right. Yeah.
Okay. No shade to the right, correct? Since it's at least.
Yeah.
Okay.
All right, so I still have to open my applet.
You're fine.
Okay. Okay, did you get 0.158 or 9?
What was that one more time?
0.159 by chance?
I
No?
got 0.139.
9, okay. Was your z-score 1.087?
Yeah.
And you shaded to the right?
Uh-huh.
Okay, I'm just trying to figure out what I did wrong here.
I wonder if I can...
Oh, yep, it changed. I just had to hit enter there.
Oh, okay,
0.129.
gotcha. Well, at least I can screen share now.
Can you?
Yeah. Not that we really need to right now.
Hey, yeah, there you go. That's cool. I still need to figure out how to do that.
Yeah.
Okay. Alrighty, so you ready for 14?
Yes, I am. I'm going to turn that off. Sorry.
Oh, you're good. Don't worry. So if the true proportion of people who support a political candidate is 0.52, and if 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. What is the standard deviation of p-hats?
Oh boy.
Fun stuff. See.
Let me redo that. I think I messed that one up.
Okay. So the numbers on top of the equation, what did you use for, did you just put
Well,
0.52 on top?
well, since this is the standard deviation, you don't have to worry about those numbers on the top.
Oh, yeah, because that's the z-score.
Right.
Okay,
Yeah, this is just the bottom half, the square rooted.
yeah. Gotcha. 0.011 or 12,
Yep,
I guess.
that's what I have. Wait, did you say 0.011?
That is what I said.
Okay, sweet.
Is that what you got?
Yeah. Then what z-score would you use? So for the top, we do 0.011 minus 0.52.
Yeah.
Okay.
That's right.
Oh, wait, sorry, that's the standard deviation I was looking at. Not p hat. So p hat is
Oh, wait a second. Yeah, never mind.
p hat would be
Since p hat isn't like listed there or shown, would we just use p?
I think for this, because I remember in the videos, there was one problem dealing with elections, and he referred to the 50% part, which is what we are looking at here in this question.
Mm-hmm.
So I want to say that we just do 50% of the sample size.
So just 1,000.
I think so, but I'm not sure. If we did that, it would be, I'm pretty sure, 0.5. So 1,000 divided by 2,000
Yeah.
would be 0.5. And then on top, it would be 0.5 minus 0.2. I mean, wait, yeah, 0.5 minus 0.2.
Okay.
So I'm not sure about that, though.
I'm gonna be honest. I didn't read or I didn't watch the video. So
You're fine. If that is the case, though, then the number at the top is going to be negative 0.02.
So the number at the top of the equation.
Yeah, the p hat minus p.
Yeah. Okay. Gotcha. Okay. And then just under the negative 0.02 would just be our regular formula. Is that?
Yeah, but since we already did the formula for question 14, you can just plug in that value.
Oh yeah. Okay.
A little shortcut there.
Yeah, you will. Okay. I need to go back over, over this section. Okay. Negative 2.14. Okay, did you get negative 1.81 or 82, I guess?
Negative 1.818.
Yeah,
Yeah,
Yep.
that's what I have.
818. That's right. Okay. Last but not least, what is the probability that survey results will show the candidate is losing even though the true P equals 0.52, round to 3 decimal places?
All right. So for this, do we shade to the left of the negative z-score?
I don't know.
That's what I was thinking, because it's talking about losing, so you'd have to get less than the 50%.
Yeah, that makes sense. Okay. All right, thank you. And then, negative. Okay. 0.0345.
Yeah, that's what I have, or 0.035,
Yeah.
which is a pretty small number.
That is kind of small.
But I can go ahead and submit mine. We can see what we did right and what we did wrong.
Okay. Go for it. Thank you.
100%.
Really?
That is what I am talking about.
Oh, a happy day.
That's for sure.
Awesome. Well, good job.
Yeah, you as well.
Thank you. Well, I can go ahead and post the video.
All right, sounds good.
And I guess we'll talk to you on Thursday.
Sweet, sounds good. Have a good couple of days.
You too.
May
Have fun,
the
Rob.
lack of nerves be with you tonight.
Wait, what was that?
May the lack of nerves be with you tonight as the polls keep on coming out.
Yeah, likewise.
All righty, see you later.
Yeah, bye.